we saw that most operations that we used didn't actually affect the original data frame that we worked with. So for example, if we rename some columns using the rename function and give a dictionary to rename those columns, whose names we want to change. So we want to rename family to F and genus to G. You see we get a new data frame with this modification. But then if we display the original data frame again, we see that nothing has really changed in the original function. So pretty much all the operations we saw, they don't affect the data frame itself. They just return a copy with this modification. But if we actually want to modify the data frame that we have, we can instead, providing those functions the inplace argument and set it to true. And you see that now the syntax is different. Now I don't assign the result to any variable. Now rename, instead of returning a new data frame, it just performs this operation in place on the data frame itself. And then the next time that I try to access the data frame, I see that it has actually changed. And this applies not only to the rename function, but also to other functions like sort values, sort index, drop, fill in a. Pretty much any function that we learned can accept this in-place argument. And you can just perform them one after the other. And you see that by the end of this process, we have that the data frame has changed quite significantly, with all the operations that we performed taking place on the actual data frame. Now, the reason that the design of Pandas is not to perform things in place by default is to allow us to do this operation chaining, which is really a hallmark of functional programming. So by getting everything as a return value, we can take the return value after some operation and then use some other function to make more modifications and more modifications on top of that. And each time we can modify it more and more. So here you can see some example of some quite sophisticated logic that we can apply by chaining these operations, just applying them one after the other. So you can see we can first slice some part of the data frame that we might want. So we want, let's say, only 9 specific records, and just the 2 columns, the inner and average radius. And then if it's null, we want to fill it with 0. And then we want to divide that by the value of the outer radius. So we use the div function. Then we can give it a series with the same index. And by stating that we want the x is 0, we make sure that the division is indeed according to the records. So for each value, we'll get either the inner or the average radius divided by the outer radius. And then we can use the apply map to say that if it's bigger than 75%, we want it to be big, and otherwise we want it to be small. And with just one Python command, which is a chaining of many operations, we get all of these manipulations done right one after the other. So we can see for each record whether its inner radius and average radius are more or less than 75% of the outer radius, say. OK, so we saw at the beginning that we can use the read CSV function to read data frames. And we can use the toCSV function to write and save data frames to files. It's very simple. We just use the data frame object and call the bound toCSV function of this object and provide a path to save the file. And in this case, I used my records CSV. And you can see that I created this my records CSV file, which I can then open and get the data frame that I created with all the modifications that are made to the original data frame. You can also see that by default, it does write the index as the first column without a header. But in this case, the index is not interesting, just the values. And if you remember, actually, the original data frame that we started with, we loaded it from a CSV file which didn't even have an index. So it's very common. We are not really interested in the index. And we can use the index equals false argument to not save the index. Sorry. Yeah. And we can also use compression. If it's a big file, we can store it with a .gz suffix and use the compression gzip. And you see that we get a gz file, which is much smaller, but contains the same data. And when you want to open a gz file, you actually don't need to use the gzip module. So Pandas will do it by default. So it knows how to recognize gz files. And you don't have to provide any argument. It just recognizes and deals with it by default. OK, and the final topic I wanted to cover was settings. So there are all kinds of settings which affect how Pandas operates. And if we want, we can change those to different values. So for example, there is a max rows setting, which its full name is Pandas options display max rows. And by default, the value is 16, meaning that every time you try to display a data frame, which will show you, if it's too big, it will show you the first 30 rows and the last 30 rows, and in between it will show these missing parts. But if we change it, say, to 2, it will just show 2 rows, one at the beginning and one at the end, and everything will be much more compact. And there is also another setting, which is called the max call width, which affects the maximum size. So you can see that for some values which are too big, then Pandas actually truncates it to not have overwhelmingly big values. So for example, if the title is too big, it will show some part of the title and then 3 dots to say that it's not everything. But we can change it. So by default, it's 50, but we can change it, for example, to a smaller value. So you can see that now everything that is more than 10 characters is truncated. And again, it looks more compact if you want that.
What are the units?
A number of letters. So 10 just means 10 letters. So you can see, and by the way, this includes, I think, the 3 dots. So it will show you, what is it here, 6 or 7 characters, and then just 3 dots, and that's it. There is also a float format, which determines how floating numbers are shown. And again, you can, that's actually a function. So you can override it and set it your own function, which gets a floating number and returns a string. And for example, if we want just to show 2 digits after the decimal dot, we can use this function. And now you can see, for example, that resolution is shown as 3.50. Now, very often, we don't want to change the settings of Pandas across the entire program. We might want to do that just in a particular scope of the code. And for that, we can use a kind of with statement with specific context. And that works with PD option context, which gets first the option that you want to alter, and then the value. And you can specify as many as you like. And then this new setting will apply only within this context. So when we do display data frame within the with statement, now we show 10 rows, like you see here. But now when we are outside, we resort back to the previous value which we set, which was 2, like here. And this is just a handful of all the settings which Pandas gives you. If you want, I put you here a link to all the settings there are, so you can look it up and see if you find more useful stuff. And that's pretty much it. I wanted to also say a few words about the readCSV function. So in our case, we use a quite basic CSV file, so we didn't need to specify any arguments. But like you saw, some CSV files are a bit different, and actually the read CSV is very, very flexible. So it can handle pretty much any input that you try to throw at it. So for example, it has the sep argument, which will accept any delimiter, not only commas. You have things like the true values, false values, and NA values, which can specify a set of strings which should be treated as trues, false, or NA. For example, in many cases, you can have, I don't know, you can have an empty string referring to none, or you can have a dash stating an empty value. And so you can set it in NA values and say that you want this to be treated as a missing value. Also, if you work with very big files, you may not want to use the read CSV as it is, because it will give you just one big data frame, which might take too long and also burden too much on your memory. So there is also the iterator option, which you can use, and then you can load the data by chunks. So for example, you can ask to load it, I don't know, 10,000 rows at a time, and then iterate it with a loop. And there are really dozens more of options. So again, I put a link here. I strongly recommend you to check it out. It will really help you to handle all kinds of inputs. So to summarize our discussion of pandas, we saw that it allows us quite interactive work and very often makes Excel completely redundant. So I think once you become proficient enough with pandas, there hardly comes a time when you actually need to use Excel, because everything you can do with Excel, you can do in pandas much more flexibly and much nicely. And you can look in the data and to visualize it, as we're going to see next week, and do everything you want within pandas. And yeah, like with NumPy, I think this really gives you this nice set of building blocks that you can use to chain and create any kind of operation that you like. And it's very, very rare when you actually need to resort back to writing pure Python. So I strongly recommend you to getting used to actually using pandas and see how you can break down the kind of analysis that you want to write into those building blocks, and not be tempted too quickly to resort to just writing your own for loops and stuff like that. Also, that will take you more time to code once you get used to it, and will also be much slower. So if you think there is a way to do something in pandas, and like 99.999% of the time there is, because it's a very, very thorough library, which allows you to do pretty much everything you want. So if you think there should be a way to do it, there probably is, and just go to the documentation or Google search it and find a way to do it within pandas. It's much better to do it this way. And also, I didn't cover everything there is about pandas. So even in the upcoming homework exercise, you will likely have to learn some more stuff that we didn't cover. And in 2 weeks from now, we're going to learn a little bit more advanced stuff that you can do with pandas. So we're going to see how you can group and aggregate data, which are more complex kind of analysis we might want to make, and merging different data frames is also something we're going to look at.